Today we're going to be talking about geometric probability. Probability that involves a geometric measure is called geometric probability. So first we're going to look at a segment. So we're going to say a point is chosen at random. So we're saying if a point M is chosen at random on segment RS, then the probability M is on KL is the length of KL over the length of RS. So let's look at this one. Point X is chosen at random on AD. What is the probability that X is on AB? Well, AB is length 8. The whole thing is 16. So 8 out of 16 is 1/2 or 50%. And again, you can write it as a decimal, a fraction, a percent. All of those are valid. BD. BD is from here to here, so that's 2 plus 6 is 8 out of 16, which is still 1/2 or 50%. So you go ahead and try the next one. Our whole length is 10, so the probability of M going on ZQ is going to be 2 out of 10, which is 1/5, which is 20%. QP, 3 plus 5 is 8, so 4/5 or 80%. All right, a spinner is a form of geometric probability because it depends on how big each of these slices are. So what is the probability of the pointer landing on purple? Well, purple's here. So it's got this portion of the circle. So its probability is obviously going to be higher than these smaller ones. Well, it's going to depend on the central angle here. So the probability of purple is going to be 120 over the entire circle, which is 360. So this ends up being 1/3, which is 33%. Okay, pointer not landing on red. Okay, if red takes up 20 degrees of this circle, all the rest of this is going to be 360 minus 20, so 340 out of 360, which as a reduced fraction is 17/18, which is 94%. All right, you try the next two. Okay, so hopefully you got 100 out of 36 for our green, which is 5/18 or 28%. Not landing on yellow. If yellow is 40, that leaves 320 for the rest of the circle, which is 8/9 or 89%. So geometric probabilities can also involve area. Okay, so in general, what the probability is, it's the same kind of idea. It's going to be the probability of your favorable or shaded or whatever they're asking area over the whole area. So not probably. Okay. So we've got a bullseye looking thing here. So if the diameter of the circle, the center circle is 4, and the circles are paced 2 feet apart, if a point is chosen at random, what is the probability that the point is in the center? So it's the probability of, so it's going to be this area, which is going to be pi 2 squared, because that's our radius, over the whole area. Well, if this is 2, this is 2, this is 2, that radius is going to be 6. Okay, which if you do this is going to be, well, the pi's will cancel, so you'll just have 4 over 36, which is 1/9 or 11%. Okay, what is the probability of the middle ring? Okay, so if I just wanted that. All right, let's think about how we would find that area. Well, that area is going to be the outside minus the inside. So that would be pi, the radius from here to here is going to be 2 plus 2, which is 4, minus the inside is pi 2 squared, over the entire area is still pi 6 squared. You do this, you'll get 12 out of 36, which is 1/3 or 33%. And obviously you have a calculator to help you with all of these calculations. All right, so I want you to try the next one. All right, So the desired area is the circle. Area of that circle is pi times 10 squared. The entire area is the rectangle, which is 120 times 30. Dump all that in the calculator, you get this decimal, which is equal to 8.7%. So a few more area problems. Find the probability that the area is in the shaded region. Well, in this diagram, all of these triangles are the same area, so it doesn't really matter how big or small it is. Shaded, we have 1, 2, 3, 4, 5, 6 triangles out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, which would be 2/3 or 66.7%. Okay, this one, we want to find the area of the shaded region. Okay, well, to do that, I need to find the area of the circle and subtract the square. So the circle is going to be pi r. We need to find the radius. Okay, so if this is 2, this is 2. I'm going to say 2 squared plus 2 squared equals the diameter squared in the triangle. So my diameter, if you do that math, is 2.8. So if this is 2.8, my radius is going to be half of that, or 1.4. So pi times 1.4 squared gives me about 6.2. Then I'm going to find the area of the square, which is just 2 times 2, which is 4. The shaded region is going to be the circle minus the square. So that's going to be 6.2 minus 4. So my shaded area is 2.2. So the probability of the shaded is the shaded area 2.2 over the whole area, which is the circle, 6.2, which gives us 0.35 or 35%. All right, you do the final two. So this one, after counting, 3 of the 9 are shaded, so that's 33%. This one, we wanted to find the area of a trapezoid, which is 1/2 times the height times the sum of the bases. The height, this is going to be a 3, 4, 5 triangle, so that height is 4. This length, 3 plus 4 plus 3 is 10. This is 4, so that's going to give me 28. The shaded area is the square, is 4 times 4, so the probability is the 16 over the trapezoid, 28, which gives us 57.1. So that is geometric probability.